you don't have a file.
No, I don't have one. In fact, the first time I heard of a PPT file was when I received the email from Lev Weidman. I now know what a PPT file is, but I have not graduated to the stage of being able to produce one. I also was not aware of how flexible the definition of 3 minutes will be in this hall, so my talk will take less than standard 3 minutes. Thank you. One of the most persistent urban legends in physics is that for a finite number of degrees of freedom, the canonical commutation relations have only one irreducible representation. Mathematicians have known, at least since 1968, that this is not true. But the counterexamples they produced could not claim to be relevant to physics. Then, in 1988, Helmut Reh showed that the representation of the canonical commutation relations for a charged spinless particle subject to the Aharonov-Bohm effect was unitarily inequivalent to the standard Schrödinger representation. Since particle states belonging to two inequivalent representations of the CCR cannot be superposed upon each other, it may be possible for two identical charge bosons to be in close proximity without interacting with each other. I have called this effect superseparability, and an experiment based on the Aharonov-Bohm effect is suggested to verify or to refute it. If the experiment proves to be feasible, its result, be it positive or negative, will have profound consequences. If superseparability is observed, it will point to a hitherto unknown class of physical phenomena. If it is not observed, then theoretical physicists will have to ponder once again the question that David Hilbert asked Rolf Nevanlina in the late 1920s. Tell me, Rolf, what is this Hilbert space that the young people are talking about? Thank you.
Thank you very much.